Hi, welcome to the Integrated Health Support System CA1 Screencast by Ceara Treacy. I'm just going to give you an outline of the screencast. We're going to have our problem statement, we're going to have our problem motivation, we're going to talk about the problem research, MySQL table structure, rules for the system, discussion of how the tables fit together, program outline, and code and demonstration. So our problem statement is currently a baby's child and child's immunisation is in the personal health record book. This is a record that is given to a new mother after the birth of her child in the at the first postnatal visit. The book is the only record the parent guardian has of the immunisations their child has received. We see that the book is liable to wear and tear in an event of loss and accident damage. The book and child's health records are in danger of being lost, although there are copies given to the people who administer the immunisation and the health nurse. These are only carbon copies and can get lost. Our problem motivation is the focus of this project will be on the recording of the administration of the immunisations by the family doctor or the practice nurse during scheduled health check visits from birth to 11 to 14 years. We propose that the hard copy version of the PHR book will be given to parents, guardian, alongside the option of the trial electronic PHR that we're developing. The idea came from Ruth in our group, and when the problem was stated, she thought this would be an ideal problem to look at, as there's no system currently. So what we did in the lines of research is we talked to Fiona, our real life mom, and to Ruth, and talked to them about what issues they had in relation to the immunisation, and they felt it would be a great idea if there was a system where all records could be kept online and kept by the GP. A discussion with the district health nurse just reinforced the idea that the record should be kept by a GP. A discussion with the GP was that he thought that it was a really good idea, that there would be less issues with forgetting the book or the book being lost, and then immunisation records would always be up to date. So our research was looking into the eWeb book. It's your baby's digital health record in the UK, as they have just this year put it online, and they've been running the eWeb book for 10 years now. No, but the system is just online. The red book has been running for 10 years. So I'm going to move on to the MySQL table structure. So on our first visit, our first meeting after the problem was brought into our CA1, we brainstormed and came together with tables that we thought would be in our database system. And from this, I went away to MySQL workbench and created tables with that we had decided on, and brought it back to the group. Since that, Ruth created the relational scheme diagrams detailing the primary and foreign keys relation, and Mark created the use case diagrams to capture the interactions between the two users of the system, namely the guardian and the GP. On our second meeting, we visited the tables and just the layout of the immunisation. The UML class diagram was done up by me. We have had 4 versions of this, changing rows and columns, mainly in the immunisation table, and then making sure that we had all the information we required in all of the other tables and how they were going to be connected. The guardian and child each guardian have one or more child, and each child can have only one guardian, so it's a one-to-many relationship. And the child to GP, each child can only have one GP, and each GP can have one or more child. This meant that there was a junction table that needed to go in here. The immunisation table had the age that the immunisation was due, what immunisation it was, whether it was the 2 month, 4 month, 6 month, 12 month, and then the description of the immunisation, and then how many injections the child actually received. This is linked into the child has received table. Each child can receive many immunisations, but each immunisation can only have one child. So it's a one-to-many relationship. This junction table connects the child has received immunisations to the child table, and the GP practices, you can get a record of what the child has actually received. The rules for the scheme was done in the MyPHR, the relational scheme. So we have at the top here the guardian table. So this is a relation scheme diagram. So we have all of the information, the columns that are to be filled in. Primary key here, the guardian is the parent table, because of the one-to-many relationship. The person with the one, or the table with the one, is the parent table. The child table is the child table. So the primary key here is the guardian's PPS number. If we move it over, we can see that the foreign key is the guardian PPS number, which is carried from the guardian's table into the child's table. Then we move to the child's table. It's a parent table of the GP practice has child table, because there's only one child, one GP practice. It's a parent, and it's a one-to-many relationship. Primary key here is the child PPS number, and that goes in to make the foreign key in this table. Foreign key is also the GP practice / ID GP practice for this table. The GP practice table. The GP practice table has then the ID GP, so this is the ID of the GP's practice, that goes into the table, into the GP practice has child table. We move down, child has received, this is the immunisations the child will have, it's the ID of the immunisation received, the ID of the received, the child's PPS number, GP practice, the immunisation and the date received. So this is actually taking information from 3 other tables: the child table, the GP practice table, and the immunisation. So this is the linking table, junction table for all 3. So the immunisations go into this table. The foreign key in that case is the immunisation, the ID immunisation. Foreign key that the child has received are these: child PPS number, ID GP practice, and the immunisation, the ID immunisation. And then the primary keys are the same. So then we moved on to the programme. So at this stage we had 2 meetings under our belt when we started to look at the programme. And we revisited the tables with more, made a few adjustments. Bridget made adjustments to the database tables that she had put into MySQL. I looked at the relation or the UML class diagrams, and Ruth looked at the relational scheme diagrams, and Mark created the workflow diagram for the programme. And this is the workflow diagram. We have a main menu where the registration happens, and then we have the second menu where you can add a guardian or child, add an immunisation, search for a guardian or child, display all records, or return to the main menu. So if we go into the programme, this is the start of the programme. So class, this is our main this allows input from the user, connection to our database, a Boolean, and this is where you can have the first part where you can register details, log in, or exit the programme. There's an if statement here, If it equals 1, you go into this, the register user method, and if it equals 2, you go into the login user method. So Mark wrote this for registration into the GP system, which was based on some of the code that we did in class, and then there's a statement here of the results. If the user already exists, it will bring you back to the menu where you can log in. So then we have a prepared statement up here to log into the system, or to connect to the system. This is connecting the program to our database system. That prepared statement is brought in. Select star from the GP practice where the IDGP is practiced. So this is where you're selecting from the database this particular variable. The program was divided into methods. Mark did the skeleton up, we wrote the methods, and then just slotted them into the program. We had tested the program in each of our computers to make sure that everything worked, and we had decided on the naming of all of our variables and the names of all of the titles in our database system. So then that's the login. This is the system where you can, this is the part where you can choose add new guardian and update, search for guardian, view all guardian child records, and this is the one I did here, view all guardian child records. So there's an if-else statement. If you 1, you can do this method, or if it's 2, you do this method. If it's 3, this method, and this is down to me. Else if 4, you do this method. So a simple print, please enter 1 for all guardians, please enter 2. So the string enters is the next line. So depending on what the input user does, if it enters 1, you go to this method, view all guardians, in accordance to this, and else if the user enters 2, then you go to view all child records. So we will just go down to that section of the code that I did. So view all guardians, we pull the connection in the parameter of the scanner, which is not needed in this case, into the method. Simple print out view all guardian. So then we have a try statement where the prepared statement we can connect to the database. Select star from guardian means select all from the guardian, and the result equals the user executed or execute query. So a while statement or a while loop is put in here to make sure that the program actually took every record out of the database system, and while there was results in the database system, it would still pull the information out. So we created our variables here. The get is where it is to get the last name, which is the part 3, is column 3 in the database. Int is for the mobile, and then this is a simple printout statement, and your guardian PPS number, which is our variable, which they'll pull from the database system, and then just a comma and a space. And we have first name, last name, address, and print. So if we just run the program, then we have a catch for the try and catch, and an exception, and then we have the return false. So if we go 1, 2, we log into the